Hello there, this is a film about ionic substances and in particular how we name ionic substances if we're told their formula and how we write the formula for an ionic substance if we know its name. And hopefully by the end of this film you'll be able to do what I just said. Basically you'll be able to predict the formula of a substance when you know its name. In order to do this, it is really important. I can't really overstress how important it is that you remember the formulae of the ions that are on the ion list that you've been given. Okay, and you'll also be able to name a substance by looking at its formula. Okay, so here we go. It's basically just a number of examples, but I'll talk you through how we're thinking up the answers. Okay, so when you put ions together, because the compound has to be neutral, that is to say it has no charge overall, the charges of the two ions that are going together to make the compound, those charges have to balance each other out. So I could look this up for the time being if I'm a novice at this, but if I'm more experienced I ought to be able to remember these formulae and charges. I can look up the potassium ion on my ion list. I can look up a chloride ion and see that they're 1 plus and 1 minus. To get those charges to balance, I'm going to need one of each of those ions, so the formula is simply KCl. Okay, and the overall formula for the compound does not show the charges of the ions. Okay, so they should not appear in the formula of the compound. Let's try a slightly more difficult example. Okay, magnesium bromide. Again, a novice might look this up while they're getting used to the idea that these ions have different charges and they're being learned, but by the time you do a test you need to be able to remember these. Okay, Mg is a 2 plus ion, Br minus is the bromide ion, so we in this case need 2 of these to balance the 2 plus of the magnesium, so this formula is going to be MgBr2. Okay, we only use subscripts, we don't put big numbers into these things whilst we're writing a formula. Okay, so that's the formula of magnesium bromide. One that people sometimes ask about is what happens if you've got two 2 plus ions, sorry, 1 2 plus and a 2 minus. Do you need 2 of each? Okay, no you don't, you just need 1 2 plus to cancel the 2 minus, so that formula would be MgO. And notice what I said earlier, nowhere in these formulas do we see any charge. And here's just a few more examples, but they're a little bit more difficult. Okay, and they get us to understand what we do if we're using compound ions. Up until now we've only been using monatomic ions, that is ions that are made of just one atom. Okay, but some of these examples are going to involve polyatomic ions, or ions that are made of more than one atom. Okay, so anyway, let's start with aluminium oxide. Again, looking these up if we're a novice, remembering them if we want to do a test and get it right. Okay, 3 plus ion is an aluminium ion, an oxide ion is O2 minus, so we're going to need to use 2 of these and 3 of them to both add up to 6, so we'll get 6 plus balanced by 6 minus, so it will be Al2O3. Okay, now here we've got something called a compound ion. These are both monatomic ions, they're both made of just one atom. Okay, although the formula is made of more than one of those ions, each of the ions is made of just one atom. The nitrate ion, if we look it up, is NO3 minus. So that's to say it's got a 1 minus charge, but there's 3 oxygens and 1 nitrogen. Okay, and in this case it's being put together with calcium 2 plus. Now I've written that one down first because I was talking about it first, but by convention in the formula you always put the positive ion first. So we're going to need 2 of this one to every one of them. Okay, so I'm going to write calcium and nitrate, but if I just write a 2 here, that doesn't show me that this whole ion, which is a compound ion because it's made of more than one kind of atom, doesn't show me that the whole of the ion has been doubled, so we put a bracket in and a 2 after it. And let's just try that with ammonium sulfate. Remember, ammonium is the only positive ion we need to know of that isn't a metal. Okay, so NH4 plus is the formula of an ammonium ion, so 1 plus, but with 4 hydrogens and a nitrogen, so that's a compound ion. The sulfate ion is SO4 2 minus. Notice the ending 8 means that there's oxygen as well as the sulfur. Sulfide would just be a sulfur ion. Okay, anyway, we need 2 of this ion to every 1 of that ion because there's a 1 plus charge here and a 2 minus charge there. So we're going to need to double this one. So I have to put the NH4 in brackets. I don't know how I managed to go back a slide there. Let's see if I can go forward. There we are. Right, NH4 is going to go in brackets and SO4 is not, because there's only 1 of them. Okay, and no charge is shown. So let me just circle the final formulas. Okay, so that's how you write the formulas for ionic compounds. And to finish with, if you've got a formula and you're asked to name it, that quite literally is just saying what you see. So say what ions you see in front of you. Okay, and again, you'll learn this by using your ion list regularly, and it's really important you know the names of all the ions. So this is a sodium ion, this is a bromide ion, so that is quite simply sodium bromide. Okay, this is different to covalent naming, as you'll see when we get onto covalent molecules, but for now we just say the names of the ions we see in front of us. This is a magnesium ion, this thing here in the brackets is a nitrate ion, so this is quite simply magnesium nitrate. And as I said before, we're dealing with the positive ion first and the negative ion last. This is a little bit more tricky because iron, as you can see on your ion list, has 2 possible ions. It could be iron 2 or iron 3. And now you need to think about what charge these 2 ions would have. That's a 2 plus ion, that's a 3 plus ion. And you can figure out from this formula which of those 2 you're using. And that's important because this is going to be called iron. This is a hydroxide ion, so it's going to be called iron hydroxide. But unless you state which oxidation number of iron you've got here, you're not giving the name completely and you're going to lose marks. So the hydroxide ion, that has a minus charge. There's 3 of them here with this iron ion, so this must be adding up to 3 minus, so this one must be 3 plus. So the full name of this compound, iron 3 hydroxide. But once again, you're just saying what you see there, but with this one you've got to figure out which of the 2 possibilities it is for iron and actually state it. Okay, so the last of the 3 films about ionic substances, that deals with structure and properties, and that's probably the best place to go next if you've understood everything here.